Lesson 4-7, use congruent triangles. In this lesson, we're going to take one step further with proving triangles congruent by stating that their corresponding parts are congruent. And the reason that we will use for this is CPCTC, meaning corresponding parts of congruent triangles are congruent. This is in your book on page 256, and there's a explanation of this, and you can go ahead and read the first example and write out the entire phrase. Now, given angle 1 is congruent to angle 2, and AB is congruent to DE, I want to prove that DC is congruent to AC. Now, I need to first explain or provide a reason of how to prove angle DEC is congruent to angle ABC by using the congruent supplements theorem. So let me first state the given. Angle 1 congruent to angle 2, AB congruent to DE. And now I can say that angle DEC, this one, is congruent to ABC, angle ABC, by the congruent supplements theorem. So these two angles are supplements, and they're congruent to the same angle. Therefore, these two angles have to be congruent. And now I can say that these two vertical angles, angle DCE is congruent to angle ACB by the vertical angles theorem, congruence theorem. And since two corresponding pairs of angles are congruent and a non-included side is also congruent, angle, side, angle, side, these two triangles are therefore congruent to each other. So I can just use this reason. And since these two triangles are congruent, then all their corresponding parts should be congruent. So therefore, I can state that DC is congruent to AC. And I would like you to use CPCTC. For example 2, we are given that angle SPT is congruent to angle RQT, and that ST is congruent to RT. So we can first write given, and then by the vertical angles theorem we can state that angle PTS is congruent to angle QTR, and therefore we can state that triangle PTS is congruent to triangle QTR by angle side. Now we want to prove that PR is congruent to QS. So the next step, we have to state that PT is congruent to QT by CPCTC. Corresponding parts of congruent triangles are congruent, so that in the next step we can state PT equals to QT and ST equals to RT by definition of congruent segments. But we need to add another step and do PT plus RT equal to QT plus ST. And this would be the addition property of equality. And by the 7th step, we can go ahead and conclude that PR is equal to QS by the segment addition postulate. And then we need to change it back to congruence as stated in the proof. So segment PR is congruent to QS, segment QS by definition of congruent segments. For example 3, we are given that angle 1 is congruent to angle 2, and that angle 3 is congruent to angle 4. And we want to prove that triangle ABD is congruent to triangle ACD. Okay, first of all, because angle 1 is congruent to angle 2, we can conclude that these two angles are congruent by the congruent supplements theorem. So first of all, let's write down given, and let's first state that DE is congruent to DE by the reflexive property of congruence. And our goal here is to first prove these two triangles congruent so that we can go ahead and prove the other two. So let me first state that angle BDE is congruent to angle CDE. Okay, and then therefore triangle BDE and triangle CDE will be congruent to each other by the fact that this angle is congruent to this angle, and this angle is congruent to this angle, and this side is congruent to each other, so we have angle side. So now we can conclude that BD is congruent to CD by CPCTC. And AD is congruent to AD, again by the reflexive property of congruence. And since we already stated that angle 1 is congruent to angle 2 by given, we therefore have side, angle, side. Side, angle, side. So triangle ABD is congruent to triangle ACD. Example 4. Given that GH is congruent to KJ, so it would be GH congruent to KJ, and that angle FJG and angle LHK are right angles, and we want to prove that triangle FJK, so this one, is congruent to triangle LHG, this one. So for the first step, I will write given. And for the next step, I will write HJ is congruent to HJ by the reflexive property. And it is pretty much implied that if GH and KJ are congruent to each other and HJ is congruent to HJ, then GJ would definitely be congruent to GJ would be congruent to KH. So here I added these steps in here. So if I don't limit you and I really want a detailed proof, I do expect you to show all these steps. So for step 3, I stated that GH is equal to KJ and HJ is equal to HJ, and this would be by the definition of congruent segments. And for step 4, I will use segment addition postulate. I stated that KH is equal to KJ plus HJ, and I did the same for GJ. And then for step 5, I substituted GH from step 3 for KJ, so then I can say KH is equal to GJ by substitution. So both steps 5 and 6, we can say their substitution. And then I need to change it back to congruence form, so definition of congruent segments. So then therefore, by the time you get to step 8, we can state that triangle JFG and triangle HLK are congruent by the HL theorem, because this side is congruent to this side, and this side is congruent to this side is congruent to this side, and these two are right triangles. So we can therefore state that FJ is congruent to LH by CPCTC. And we can also say that angle KJF and is congruent to angle GHL by the congruent complements theorem. So therefore, we can say triangles FJK is congruent to triangle LHK side, angle, side congruence. Example 5. Write a proof to verify that the construction for copying an obtuse angle is valid. So given that AB is congruent to DE and AC is congruent to DF and BC is congruent to EF. And we want to prove that angle D is congruent to angle A. So again, we write the given. And since all the sides are congruent, triangle CAB is therefore congruent to triangle FDE by side postulate, and therefore the corresponding sides are congruent. Angle D is congruent to angle A by CPCTC. Okay, and we'll continue more proofs in class.